This conference will now be recorded.
Good afternoon, all.
Good afternoon, ma'am.
Good afternoon.
Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon.
Good afternoon, ma'am.
Very good
Good
afternoon.
afternoon, ma'am.
Good afternoon.
Good afternoon, ma'am.
Yes, good afternoon. You should join the class before 5 minutes. 1:25 you should be in the class. Okay. So we'll start our class today. So already I have given the syllabus. We discussed what is pharmaceutical organic chemistry theory subject, what are there in the syllabus. So before we start, I want to ask you, what is organic chemistry? So what do you mean by organic chemistry? You have studied chemistry subject, right? Nia Jo,
Yes, ma'am.
what do you mean by organic chemistry?
The study of carbon and its derivatives.
So it's nothing but organic chemistry. Good. So why we need to study organic chemistry? Why is it important? Prajwal? Prajwal,
Yes, ma'am.
why we have to study organic chemistry?
Because all the living organisms are made up of carbon, majority of the living organisms.
Only living organism?
And some of the materials,
Examples?
examples like no.
Okay. So every living organism is made up of organic molecules. So organic molecule is nothing but the carbon compounds, the proteins that make up our hair, skin, muscles, and almost the DNA that controls your genetic heritage. So everything is made up of carbon, that is organic chemicals. The food that what we eat, that is also made up of organic chemicals. Please unmute yourself. Prashant. The clothes what we wear, that is also an organic chemical made up of. And importantly, what we are studying, the medicines, what we take the medicines, it is all made up of organic molecules, that is carbon molecules. So hence we need to study organic chemistry. So what is the difference between organic chemistry and pharmaceutical organic chemistry? Shashank?
Don't know.
Don't know. There is one word, right? Pharmaceutical, organic chemistry, organic chemistry. So what is pharma? Pharma? Pharmacon means drug. So pharmaceutical is related to drugs. So you are mainly concentrating on the drug molecules here. So organic chemistry is a vast branch. It includes so many things. But in your syllabus, we are studying and concentrating only on the drugs, that is medicines. Hence, the pharmaceutical organic chemistry. So whatever the chemistry we are studying, The organic compounds all are medicines. So it should have a medicinal use. So organic chemistry is nothing but the study of carbon compounds. So carbon, what is the nature of carbon? The atomic number of carbon is 6. And where does it belong in the periodic table? It belongs in the second row element in the periodic table. So although carbon is the principal element in organic compounds, most also contain, along with carbon, what it contains?
Hydrogen.
Along with carbon compounds, it contains, most of them contain hydrogen. Very good.
Hydrogen.
Yes, good. And may contain, along with carbon and hydrogen, what it may contain?
Functional
Halogens.
compounds.
Yes, halogen or nitrogen, oxygen, phosphorus, sulfur, chlorine, anything it could be, or other elements. So, but the principal element is carbon. Along with that, the other elements can also be present. So, unique ability of carbon atom is to bond together. So, one carbon can form a bond with another carbon. So, carbon they can form
Catenation.
a bond. Yes, and forming long chains and rings. So, carbon can form n number of lengths. So, it could be at least like methane. Methane is how many carbon?
One carbon.
One carbon. What is the molecular formula?
CH4.
Yes, very good.
CH4.
So for n number of carbon, example, any compound? DNA.
Origin.
You know the DNA?
Yes,
Deoxy.
ma'am.
What is DNA stands for?
Diribonucleic acid.
Deoxyribonucleic acid.
Deoxyribonucleic acid.
DNA. Yes, deoxyribonucleic acid.
Nucleic
So
acid.
it is having tens of billions of carbon. So it is countless. You can't count actually, right? So that is the ability of carbon, unique ability of carbon, and form an immense diversity of compounds. I have given example, methane to DNA. So methane is having only one carbon, DNA is having billions of carbon. So we'll study one by one. So we'll start with the atomic structure. So what do you know in atomic structure about the atoms, molecules? So what do you mean by an atom? What does an atom consist of?
Proton, neutron.
Alas, particularly
Electron.
Nikita? Atom consists of? Nikita, are you there? Anusha?
Yes, ma'am.
Yes. What does an atom consist of?
Proton, neutrons, and
Only
electrons.
proton, neutron.
And electrons.
Atom consists of a dense positively charged nucleus surrounded at a relatively large distance by negatively charged electron. The nucleus consists of subatomic particles called neutrons, which are electrically neutral, and protons, which are positively charged. So you can see the diagram of an atom. So in the center, what it is? It is the nucleus. So nucleus consists of protons and neutrons, whereas electrons is revolving around the nucleus. So next we need to see what do you mean by atomic number, mass number, and isotopes. Neha is there? Neha? Nimisha?
Yes, ma'am.
Yes. Can you tell the definition of atomic number?
So atomic numbers are always equivalent to the number of electrons.
No.
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 Like it's defined by Z.
Hmm.
And they're on.
What number it gives? Atom. Which atom? Which
Sorry, ma'am. I didn't get it.
atomic number? So it is some number of what it is.
It's a number of the element.
Number of?
Protons.
Yes. Number of protons in the atom's nucleus is nothing but atomic number. So only the number of
Protons.
yes, number of protons gives atomic number. So it is designated by Z. Kushal,
Yes, ma'am.
what do you mean by mass number?
Ma'am, the number of protons and neutrons, ma'am.
Yes, it is the total number of protons and plus neutrons will give you the mass number, and it is designated as A, indicated by A. Dheeraj,
Yes, ma'am.
what do you mean by isotopes? Have you heard about this?
Yes, ma'am. I've heard of isotopes.
Yes, can you define them?
Ma'am, it's like isotopes are the ones that have the same atomic number or like same
Yes.
protons, ma'am, but
Yes.
they have the different neutron number.
But different mass numbers.
Yes, ma'am.
Atomic number, mass number. They have the same atomic number, but different
different
mass number.
numbers.
Are called isotopes.
Isotopes, yes, ma'am.
Yes, very good.
Thank you.
So this is about what is an atom, what is it comprises of, what do you mean by atomic number, mass number, and isotopes. So next we'll move on to orbitals. So what do you mean by orbital?
The pathway in the which electrons move.
Yes, where especially the electrons are present.
Different locations of electrons.
Yes. So what shape do orbitals have?
Spindle shape.
They have dumbbell shape,
different kinds of
tetrahedral,
orbitals.
octahedral.
First, there are 4 different kinds of orbitals denoted as s orbital, p orbital, d orbital, and f orbital. So these are the 4 important different kinds of orbitals here to study. So out of this, we'll go one by one. What is s orbital? S orbital is what shape? What is the shape of s orbital?
Spherical.
Spherical. Yes. S orbitals are spherical. P orbitals
Spherical. Dumbbell shape.
Dumbbell shape.
That is dumbbell shaped. What about d orbital?
Double dumbbell.
Tetrahedral.
Double dumbbell.
Double dumbbell.
Double
Double dumbbell.
Yes, it is called clover leaf. CLOVER, clover leaf shaped.
Double
orbital.
dumbbell.
Yes, double dumbbell. And what about f orbital?
Tetrahedral.
Double dumbbell.
Octahedral.
Shape of f orbital. What shape you can see?
Dumbbell clover.
Huh?
Nothing, ma'am.
Shape of f orbital.
Is it hexagonal, ma'am?
It's a tetrahedral structure. But mainly we are concentrating only on s orbitals and p orbitals. Why? What is the reason we are concentrating only on s and p orbitals? Because these are most important in organic chemistry, s and p orbitals. Hence, we are going to concentrate only on the s orbitals and p orbitals, not on p and s. You can see what is this? Different,
Different orbitals.
yes, different orbitals. So center there is a nucleus and you can see the electrons. So the first shell has how many electrons?
2.
Two
Two
electrons.
Two
You
electrons.
can see here, right? 2 electrons in the first shell. Second shell, how many electrons?
8 electrons.
8 electrons.
8 electrons. Third shell,
18 electrons.
18
18
18
electrons.
electrons.
So you can see as we move on from away the nucleus, there is increase in electrons. And these are the different p orbitals. There are 3 p orbitals. What are they? px orbital, py orbital, and pz orbital or pz orbital. Okay. So each orbital can occupy 2 electrons. So p orbital can occupy how many electrons? px, py, pz. So it will be 2 plus 2 plus 2. 6 orbitals. So 6 electrons. Please unmute yourself. So next is electronic configuration. So what do you mean by electronic configuration? So electronic configuration is the distribution of electrons of an atom or molecule in atomic or molecular orbitals. Is nothing but electronic configuration. So according to the laws of quantum mechanics, for systems with only one electron, a level of energy is associated with each electron configuration. And in certain conditions, electrons are able to move from one configuration to another by the emission or absorption of a quantum of energy in the form of photon. So we'll see this later on, like how the energy level changes from ground state to excited state, from excited state to ground state. There is change in electron configuration. So this is important in studying the hybridization of carbon atoms, that is sp hybridization, sp2 hybridization, and sp3 hybridization. So what is hybridization? What do you mean by hybridization?
Overlapping of the orbitals.
Yes, overlapping of
Orbitals.
orbitals to form atomic orbitals overlap each other to form a new orbital. It is called hybridized orbital. So they are going to form a new orbital. They are called as hybridized orbitals. So hybridization is also an expansion of valence bond theory. So what is the difference between these two structures? Any change you can see?
structure.
So this is the structure of water molecule. I have written two different ways. One is Lewis structure and the other is Kekulé structure. So what does Lewis structure say?
Number of electrons shared.
Number of electrons says Kekulé structure.
Shared.
Yes. Lewis structure is also called as electron dot structure. We are representing the number of electrons here. Whereas in Kekulé structure, we are going to represent as line bond structure. So you are going to write a line for bond. So it will become Kekulé structure. Next is types of bonds. So what are the types of bonds? we see mainly there are three types. One is ionic bond, second one is covalent bond, and third one is coordinate covalent bond. So what do you mean by ionic bond? So where we can see this type of bond, ionic bond? This
Between
ionic
positive
bond
charge
is
metal.
Metals, ma'am.
mainly seen in inorganic compounds, especially the inorganic. They are charged particles. So the inorganic compounds are having a charge, either positive or negative charge. So when the bond is formed between these two charged particles, that is the ionic bond. So here, a type of chemical bonding that involves the electrostatic attraction between oppositely charged ions or between two atoms with sharply different electronegativities. They are called as ionic bond. So what is the example can you give for ionic bond?
NaCl.
NaCl, ma'am.
Good. Sodium chloride.
That has
So
the metal is a
inorganic compound where sodium is positively charged and chloride is negatively charged. So both attract each other and forms an ionic bond. Any other example?
Lithium fluoride, ma'am.
Yes.
Cesium chloride.
Yes. Ammonium chloride. Then potassium hydroxide, sodium hydroxide. So all the
Ma'am, sodium
inorganic
bromide.
salts. Yes, all the inorganic salts have the ionic bond. So next is covalent bond. So what is covalent bond?
Bond
covalent
is the
bond
share.
is a sharing bond where electrons are shared.
Yes, it is also called as molecular bond. Covalent bond is also called as molecular bond. It's a chemical bond that involves the sharing of electron pairs between the atoms. So where we'll see the covalent bond? What type of compounds will see covalent bond? The organic compounds. All our organic compounds are made up of
Yes.
covalent.
Water is covalent bond, ma'am.
Yes, or the organic compound. Whichever the organic compound you are studying will be a covalent
Covalent bond.
bond. Most of the organic compounds. Example for covalent bond, you can say methane.
Methane.
Yes, CH4. So 4 hydrogens are joined to carbon atom. So how many covalent bonds are formed in methane?
4.
4.
Four.
Because yes, carbon has 4
Four.
electrons. So this 4
Hydrogen.
electrons is going to form a new bond with 4 hydrogen. Hydrogen has how many electrons?
One electron.
One
One.
electron. Yes, one carbon electron, one hydrogen electron will form one CH bond. This CH bond is nothing but covalent bond. So CH will have 4 CH bonds. So it will be 4 covalent bond. So next is coordinate covalent bond. So what is the difference between this covalent and coordinate?
Ma'am, in
It is
this case,
also
the
known as-
electrons are supplied by one of the two atoms.
Yes, this is known as dative bond or dipolar bond or coordinate bond. So these are the various names. Here what happens? The 2 electrons is taken from the same atom. So 2 atoms are involved in bond forming. Here to form a bond we require 2 electrons. That electrons is given by either of the one atom. In covalent bond it is equal sharing. I'll give 1 electron, you give 1 electron. We will make a bond. Here coordinate bond, it is not like that. I'll only give both the electrons, just you need to form a bond with it without giving any electron. So example, where we can see this coordinate covalent bond.
Hydronium ion, ma'am.
Hydronium ion. Then ammonia, NH4 plus, when you have a charged one. And when we have a complex form, and a complex form between a metal ion and the compound. In that case, a coordinate covalent bond is formed. And how it is indicated? The coordinate covalent bond is indicated by a solid line with an arrow mark.
Arrow.
So arrow should be present. Covalent bond, just a solid line. Straight line is covalent bond. Along with an arrow mark, it indicates coordinate bond or dipolar bond. So clear till now? Any doubt? Yes. Any doubts till now?
No,
No,
ma'am.
ma'am.
No, ma'am.
No, ma'am.
So now we'll move on to valency of carbon. So what is the valency of carbon? What is the valency of carbon? 4.
-4.
Plus or
Minus
minus
4.
4. Plus or minus 4.
Valency of carbon is 4.
4.
Okay. So how many
4.
protons and how many neutrons are present?
6 protons and 6 neutrons.
6 protons and 6
Protons and
neutrons.
6 neutrons. What will be the atomic number?
6.
Mass number?
12.
12.
Atomic number is 6, mass number is 12. And its valence is 4. So how the configuration is written? Configuration
2,
means what?
2.
What do you mean by configuration?
Ma'am,
1s2, 2s2, 2p.
1s2, 2s2,
Yes.
2p2.
How many electrons
carbon.
are occupied in each orbital? That is the electron configuration. Since the carbon has how many electrons?
6.
6.
How many protons? Equal number of electrons. So proton is 6, electrons will also be 6. So these 6 electrons are arranged in the orbital, outer orbital of the nucleus. So how it is arranged? You already studied in your 12th standard, right? How to write the electronic configuration. First it has to fill the first orbital. The first orbital is s orbital. Yes or no? First orbital
Yes,
is
ma'am.
s orbital, 1s. So s orbital can occupy how many electrons?
2.
1s, 2. So 2 electrons are occupied in the first orbital. So second, it is 2s. Second s orbital again. So second s orbital, again how many electrons can be occupied?
2.
So 1s2, 2s2. Next, how many electrons are left?
2.
1 minute, I'll get the charges.
2.
Just wait, my battery is going down. I'll get the charger. So 1s2, 2s2 is done. Still, how many electrons are left?
2.
2 electrons. So now, which is the next orbital after 2s?
2p.
2p. So p orbitals can occupy how many electrons?
6.
6.
6. But how many you have?
2.
There's only two electrons left.
2.
So how will you distribute these 2 electrons in the 3p orbitals?
2p2.
What are the 3p orbitals?
px,
No, ma'am,
py,
carbon does
pz.
not go to
Yes,
3p.
px, py, pz. So these are the 3p orbitals is in second, that is 2p. So this 2 electrons should be present in the p orbital.
and
So how will you share the electron or distribute this electron in the p
P
orbital?
orbit.
2px and 2py get electron.
2px 1 electron, 2py 1 electron. 2pz will be
Empty.
0. There is no electron. It is an empty pz orbital. Clear? Now, this is in the ground state. So when they undergo hybridization, they get excited into excited state. So there is there will come hybridization. Why hybridization occurs? What is the need for hybridization now?
Stability.
Yes. How does the stability come from?
Octet structure.
By obtaining an octet configuration or octet state. So why octet state? Because octet state is the most stable form. So there is chance of hybridization. So we'll study in detail later classes about hybridization. So now you have understood what is the valency of carbon. Valency of carbon is 4. Why it is 4?
Because atomic number is 6. And
Atomic number is
Two
6,
co-
so it will be 4.
like two shell, first shell occupies
Outermost.
only 2 electrons and outermost shell
Outermost.
occupies only 4 electrons.
This one,
Will
there are
need another 4
there
electrons
are 4
to
electrons
complete it.
that are there for either giving or taking.
Yes.
India.
To make it stable and to compete with the octet form, to form more stable. So 4 electrons are ready to form new bonds. So carbon atom can form 4 single covalent bonds. So here you can see how the bonds are formed in the second picture. You can see, right? Carbon atom is giving 1 electron, hydrogen is giving 1 electron. So it forms CH. So totally 4 CH bonds. So this is the tetrahedral structure of methane. So why it is tetrahedral? So whatever the covalent bond forms, CH bond. So this CH bond have same bond angle. So the bond angle is 109.5 degrees. So whichever length, whichever bond you take, whichever CH bond you take, it should be 109.5 degrees. So this bond angle is obtained when you make it in a tetrahedral form. So carbon will form a tetrahedral structure. So this is how you write the electron configuration, right? 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. So this is the order how the electrons are distributed. So since we are taken carbon, it is having 6. So 1s2, 2s2, 2p2. But again, p orbital is divided into px, py, pz. That 2 p electrons in the p orbitals are occupied in px and py. Since they are having odd electron, they have tendency to gain or lose that electron to form space electrons. So this today's class, everybody has understood. Any doubts you have?
No, ma'am.
This is a basic thing. What you have studied in your 12th standard is repeated one, right? You have all studied this in 12th standard. Yes or no?
Yes, ma'am.
Yes, ma'am.
Just a revision.
Yes, ma'am.
Yeah, good. So still we need to study what do you mean by valence bond theory and molecular orbital theory. So next we'll move on to this and then we'll go to what is hybridization What is sp2 hybridization? What is sp3 hybridization? sp hybridization. And then we move on to structure and physical properties. So under that we need to study what do you mean by polar bonds, ionic bonds, polar covalent bonds, what is meant by electronegativity, what do you mean by dipole moment. So these are we need to study under structure and physical properties. So will you take down few definitions? I'll dictate.
Yes, ma'am.
Yes, ma'am.
Take down. Definition of organic chemistry.
What's the chapter name, or is this just a introduction in general?
Introduction in the sense, before we start our structure and physical properties, these are the basic things you need to know.
Okay.
Definition of organic chemistry. Organic chemistry is a branch of chemistry Organic chemistry is a branch of chemistry which deals with Organic chemistry is the branch of chemistry which deals with study of carbon compounds. Study of which deals with study of carbon compounds. So now the new definition is study of organic chemistry is the study of hydrocarbons. Not only carbon, it includes hydrogen. So it is also study of hydrocarbons.
Should we write that down also now?
Yes. Or the study of hydrocarbons. Study of carbon compounds or hydrocarbons. Next, atomic structure. Atom consists of a dense positively charged nucleus Atom consists of a dense positively charged nucleus surrounded at a relatively large distance by negatively charged electrons. By negatively charged electrons. Next one, the nucleus consists of subatomic particles called neutrons. The nucleus consists of subatomic particles called neutrons, which are electrically neutral. Neutrons which are electrically neutral, and protons which are positively charged. And protons which are positively charged. So next is atomic number. Symbol is Z. Atomic number gives the number of protons. Atomic number gives the number of protons in the atom's nucleus. Gives the number of protons in the atom's nucleus. Next, mass number. Mass number gives the total of protons plus neutrons. Gives the total of protons plus neutrons in the atom's nucleus. Gives the total of protons plus neutrons in the nucleus. Next, isotopes. Atoms with the same atomic number. Atoms with the same atomic number but different mass number. Atoms with the same atomic number but different mass numbers are called isotopes. But different mass numbers are called isotopes. Next, orbitals. Orbitals. Orbitals, different shapes. Orbitals, different shapes. You can take down this 4 orbitals, sp, df. You can draw this by seeing the screen. Finished?
Yes, ma'am.
Finish drawing the orbitals, sp, df.
Yes, ma'am.
So these are the different p orbitals. This also need to take down px, py, and pz orbitals. So px orbitals sideways, py vertical, pz slant. X-axis, y-axis, and z-axis. So next, electron configuration. The electron configuration is the distribution of electrons of an atom or molecule in atomic or molecular orbitals. It is nothing but electron configuration. Next, according to the laws of quantum mechanics, for systems with only one electron, a level of energy is associated with each electron configuration. And in certain conditions, electrons are able to move from one configuration to another by the emission or absorption of a quantum of energy in the form of a photon. Finished? So these are the structures, two different structures of water molecule. One is Lewis structure and the other is Kekulé structure. Lewis structure is also known as anyone?
Dot
What
structure.
is the other name? Yes.
Electron dot structure.
Electron dot
Electron
structure.
dot structure. Lewis structure or
Electron dot structure.
Kekulé structure is also known as
Line bond structure.
Kekulé structure is also known as line bond structure. Next, types of bonds. Ionic bond, covalent bond, coordination covalent bond. It is also known as dipolar bond or just covalent coordinate bond. You can also call it as coordinate bond. So write the definitions for this. So what do you mean by ionic bond? What do you mean by covalent bond? And what do you mean by coordinate covalent bond? So I think you can write the definition for this, right? Covalent, coordinate, and ionic bond. Definition you need to write. So it's time up. We'll meet in the next class. So revise this once again, and we'll continue in your next class. So all of you take care. Bye.
Thank you,
Bye,
ma'am.
ma'am. Thank you, ma'am.